Obviously our three presenters here and also the two additional panelists. So Will and David, I'd like to just give you a few seconds to introduce yourselves. Will?
Yeah, sure. I'm Will Sobel. I'm CEO of System Insights. I work with Kennametal on the Nova project. I'm also the architect of the MT-Connect standard. So I've been working for about 7 years on industrial internet connectivity from manufacturing equipment, primarily discrete manufacturing, machine tools, cutting metal.
Thanks. David?
Dave Petruzzi. I run our analytics and engineering practice for our industrial customers at Genpact. Again, have been focused on the reliability and analytics side of the business, for the last 10 years and really driving, advanced analytics into that process.
Okay, thank you. So I have a couple of questions myself, but I'd like to open the floor first. Anybody like to go first? Either raise a hand or you can write it down and send it forward, sir. 1 second.
I guess this question is against William. Can you provide a little bit more background on the MT-Connect and the challenges that resolved of bringing in all that different type of equipment data?
Sure. So MT-Connect provides not just sort of a communications protocol, though it does. It uses HTTP as a basis, but it also provides a store and forward protocol layer on top of it. But what it really provides is the domain knowledge, the domain model, or the semantic layer. So when you're talking about something specific on a machine, the states of the machine, the positions, the tooling, the speeds and feeds, it's always the same, regardless of what manufacturer is producing that data. So instead of just providing sort of a way to get data from something where you get like a bunch of tags and those tags have certain values, like most PLCs provide and most device net type protocols provide, we actually define what every single word means, what every single tag means, and we contextualize it with the components that they come from. When you're doing analytics, like what we do, big data analytics across from multiple different machine tools, from multiple different sources, having that semantic translation up front gives you a huge advantage because it simplifies from the application standpoint what you have to do. Now I have a way to be able to compare A, B, C, and D without having to do this whole translation and try to reinterpret, figure out whether the units are the same on each machine. The units are always the same, the data is always the same, the format's always the same.
So once you've translated the data, how did you manage, as you increase the number of different equipment, you actually had to re-parameterize those new equipments that you're integrating in? Did you have any issues managing that?
Not really. I mean, the way the standard works is basically we have adapters which sit either on the machines or near the machines that collect the data from the machines and do sort of a first order translation into the vocabulary of MT-Connect. That gets it off of the machine. That is then sent to what we call the MT-Connect agent, which provides a protocol server. Basically, it's a web server. And that also contextualizes it within the component level model. So then we know for each of the data items what the data is coming into those data items. Units translation is also done up front. So once the data is there, then rolling it out to, let's say you have 100 machines, they all have similar architectures. We can actually roll out to a plant or configure up an agent within an hour, half hour. We can deploy the whole solution out. Again, it's open source software. You can actually download it if you want for the standard. We can deploy and configure based on generating these device configurations once we know what the machine has, what the machine axes and how they're calling them and all that kind of thing. But the data just kind of flows through. At that point, once you get it to the agent, now you have something normalized. That's actually on the shop floor side. We then have a secure connection going up into the cloud where we do all of our analytics. And the data is tunneled up into the cloud, compressed and encrypted and so forth. And we do high-speed storage.
Thank you. Anybody else for a question?
Yeah, hi. I was wondering, as you get all these machines hooked up, do you start seeing a drive where the actual equipment manufacturers then want also the data so they can take a look at the performance and maintenance on them?
We're talking to a couple of manufacturers, builders right now, who are looking into that as a service, basically being able to. It hasn't been a huge thing at this point, but I think there are some builders. I got a builder back there. Brian's going to be talking about MT Connect with Rocky from Mazak tomorrow. Call out for you guys. So he's from Akuma. So I think that's going to be coming along where, they do it in some proprietary systems, but I think from a standards-based approach, it will be coming.
Yes, I got a question. Let's see, for Adam, I guess. So for the tooling machines, did you find you had to add more sensors in order to get the right data, or did you back away from some of the data that you didn't think was important?
Yeah, we have done some work with external sensors. We kicked off a few projects with System Insights. System Insights does have some hardware solutions for legacy machines that cannot provide the MT Connect data directly from the controller. But for the type of tool analysis that we're doing, that data is coming exclusively from the controller. We're not using any external sensors.
Yeah, this is for Scott. So you mentioned that there were some challenges integrating data, stitching of data. You had data from Pi, you had data from other pieces. So is that stitching was something that you did internally, or did you actually leverage your external partners to do that?
So good question. Yes, we leveraged our external partner, and they took our data and then showed us how it could be stitched together to deliver the result we were looking for. So it was very helpful to use a company that was familiar with this. Although they didn't have a whole lot of renewable experience, they had experience throughout the market. And so they knew how to take data and stitch it together, and that was valuable to us.
David, did you want to add to that?
Yeah, no, and that's the end goal, is to make the operator self-sufficient, down the road, so they don't have to have consultants in for the rest of their lives, right? So, the process is to, build a common process, and it's really about the process, it's not about the data, but build a common process of how you're going to bring data in, what data is actually important, because we all have a lot of data, but actually very little of it is really important. And so how do you leverage and identify the important stuff and make that accessible and integrate where you need to integrate going forward? You don't have to integrate everything, right?
There is one point I want to make about data. So the old saying, garbage in, garbage out. And so it was important for us to be able to look at the data they stitched together and then validate it against something. Not just our internal data, but a best practice. For example, we went to Genpack actually pulled in another company that had data from the DOE. And then they compared what the result was from our data with that data, and it lined up. So it gave us confidence that that data that was stitched together was valuable to us.
Thank you. Scott?
I guess this question is for maybe everybody on the panel. Relates to the last question. I didn't hear too much about visualization, and I'm curious, just in hearing how the Duke folks look to bring in Genpack to come up with a, special analysis of their equipment, and then at Kennametal it looks like you had some specific analysis run. Just curious, how do you think about visualization? Is that something that has to be customized, and does System Insight do that, or does Genpack do that, or is there someone else that's got a visualization package?
Would you like me to field that question? So I will. So that is a very good question. There's two sides to that question. So when you have data and you have an engineering group looking at data, they look at it one way. If you have operations looking at data, they look at it different. They look at it in a more visualized format. So how do we balance the two? So that one of the slides that I presented was that whole platform of those buttons, so to speak, that you could click and you would be able to see different visuals of that data. So we're very cognizant of how that data is supposed to look for the audience that we want to see it. So behind that data were those failure curves or the bathtub curves. And then the front layer, we actually use some of the software applications out there like Pi. I don't know who's familiar with Pi. It's a historian. It's used quite a bit in the process industry as well as the energy industry. And so it has a very good visualization package, and so you can build these graphics. So behind the graphics is that data, those failure curves, and on the front side would be some of that. And then we would look to our partner to help us have something even more customized for the end use of, say, senior management or people that have, I always say this, but forgive me, a short attention span, that want to see data quickly and results quickly. Yeah. I'm one of those. So.
Yeah. And so visualization means a lot of things to a lot of different people. Visualization has to be role-based these days. It can't be one size fits all. And our philosophy is that there are a lot of good tools that different parts of the organization are already used to dealing with. So why create a different layer? So, we basically are looking at the overall workflow, looking at the overlaying analytics layer, and very few people actually deal in that high-end analytics layer. But like Scott said, if I'm a maintenance resource out in the field, I still want to see it in Maximo, right? I don't want to look at some other tool. I want to see it in Maximo. So a lot of our workflow then deals around how do you get it back in front of people in the visualization system that they're used to dealing in, but create an extra value layer over top of that traditional view. Okay?
Yeah, very similar on our side. I mean, our data scientists use things like RStudio to be able to visualize the data, but I wouldn't want our customers or even you guys having to play around with that. I mean, it's tons of data. We're doing extracts of terabytes and then looking at them and graphing them and playing around with various different algorithms to be able to do the fits and the correlations. And then, who really wants to do that? So I mean, we have people who like to do that. It's fun. I mean, if that's your thing. But so then we're using like Tableau as one of the products to be able to do some of the visualization. We also do some of our custom visualization. And then what you come down to is you turn it into actionable events, and that's at the end. You have to present it to somebody so it's easy to use. Like what Adam, you can talk about some of the recommendations, but the recommendations are very simple. You're saying, this is what is the best practice. Here are the options, and here's the best practice.
Yeah, so the software does include visualizations. I try to shy away from that to keep this from being too commercial. But I think Will said it well. As the user, we're primarily using Tableau, which we've built into the software. And that's because it gives us the flexibility to make changes very quickly. And I think the comments were made well that those visualizations need to be role-based. Mm-hmm. So we have a number of different Tableau reports that are for different functions. And it allows us to customize them pretty quickly. And then once we nail something down and it meets all of the user's needs, then we work with System Insights to actually code that and deploy it into the system outside of Tableau.
Yeah, and I think just to add to that, one last point is that there's different layers that you got to look at. So there's this heavy analytics layer, that is typically behind the scenes. But when you build these types of things, you want to have deep analytics, but you want to separate some of those deep analytics from business rules and how business rules are actually deployed and maintained in your organization. So you don't have to have a bunch of data scientists always on the hook to adjust those, modify those. And a lot of people try to kind of integrate all those into one, data science, algorithm. But really, the best practice is to kind of keep business rules and algorithms separate from each other so that these can be adjusted and maintained very easily by the business users.
Yeah, we coin it with a term, a hierarchy approach. So the engineers want the deep dive in the analytics, and senior management wants to just see a summary of what went on. And so you have to balance that.
We have something very similar. We subscribe to Data Raker, which is more the lower level of the layer, which they have. It's an Oracle product that they have their own data scientists that not actually just use our data, but correlates it with other utilities of similar size, correlates it with property appraisal records to make sure that the size of room is consuming the same amount of information, so that it can have a trending as well as comparative analysis between those, as well as the weather. What's happening in the weather? Are they consuming more? But those are on what Dave would say is on the lower layer, with the data scientists, probably crunch as much numbers and permutations and analysis and algorithms and to crunch them together. What you've seen in terms of our dashboarding is either a combination of a third-party tool that harness the data, do the presentation layer, and it's role-based, depending on who's going to act on it. It can be an operations field person who would, or it can be a customer rep who would call them and say there's a spike, and based on that role, they have a different presentation layer to see things that's easy for them enough to decipher and analyze, wherein the data, the massive amount of data, is actually correlated with the data scientists and putting that together. So yeah, 3 layers in terms of and then the presentation layer is customized per role, and multiple avenues of presenting them.
More questions, anybody? Okay.
Scott, did I hear you say use pi?
Yes.
And I heard Maximo.
Yes.
So did you stitch the two together? Is that?
That is correct. So that is a key component of getting the advanced analytics and prognostics working to our advantage. So essentially, we went to Genpact and said, hey, we have this work management system. We have this enterprise-wide data historian that collects an ungodly amount of data points. We need to be able to look at it. So an example is just the renewable fleet, right, has over 500,000 points. So we have 11 full-time Pi administrators. So you can imagine the amount of data that we handle.
And you think about it, they actually have other layers there. They have Bentley Win. They have so they have a lot of analysis tools already in their process, and all that's good stuff. That you need that, to keep going forward. So the approach they took was, pull all of that together, and all of those faults and all of those analysis that those are doing are great. We take those in as inputs into the larger algorithms, into the machine learning tools. Because what those help you define is what are your best actors within your fleet of assets, right? And so then we can start, doing, duplicate scenarios, mirroring the best actors and deploying models that will help run, make the rest of the assets run the same way.
Did the user learn enough now to stitch their own data, or are you always there to do new stitching, or how'd that work?
Yeah, so nobody ever wants a third party there forever. And that's the whole concept, is that they show us how to do it. We use the techniques that they're proven methods that they've used in other industries, and then essentially they move on to the next customer, and we get the results of that product.
And by the way, depending on what industry you're in, I think William said it really well. Semantic modeling of assets is really important as we go forward, because as operators, I think most operators don't want to have each OEM with a unique way of managing and maintaining assets. They want to look at it as a generic set of assets across their fleet. And so how you do semantic modeling to say an apple is an apple is really important as you go forward in this process.
Any more questions, anybody? Okay, I have one myself I'd just like to round off with then. So I'm always curious to the presenters. What advice do you have for people who are starting to do this? Or in other words, what would you do differently the second time around? Hedi, do you want to start with that?
There's always points for improvements, and anything you do after you've gone based on what you learn and the lesson learned. I would say for our purposes, it starts something small. try to understand and have a comfort level of what you're implementing, regardless of whatever technology it is. It's important to truly understand and vet that process and align that with your business rules, and then grow that. And then necessarily tune it as you grow it, because that's the only way that you'll have a controlled way of propagating that technology and the data across the organization, and a wise use and progressive use of it.
I would say embrace the concept of a minimum viable product. For Kennametal, that was a bit of a challenge at first, where we sell cutting tools, and when they go out the door, there's no fixing any quality issues, there's no fixing any bugs. Whereas with a software, it's more important to get that out in front of users, get feedback, and then make rapid changes very quickly.
Okay. I figured Will would give a few points too, but so anyhow, what would we at Duke Energy do differently? So one of the things that really came about very quickly was the renewable business. So we had generating assets 100 years old, and you did things traditionally. And what we left out of the mix was a plan. So the biggest thing that businesses forget to do is use some of the basic foundation knowledge that they used for the last 100 years. Plan. So have an approach where things are linked together. For example, your work management system, your Pi historian, your vibration data. And then all of those things are already in place, so you could bring in someone who has a software specialty and then hit the ground running. So if you have to say, well, we're not quite sure about the quality of that data because we just put it in there, it was a new part of our business, that's not a good approach. And so if we could wind the clock all the way back, I would have, if I had control of everything, I would say, this is how we're doing it. We're going to use the same concept that we used in our thermal side business and then apply it to the renewable side.
Okay, thank you. Unless there's any final questions, then we'll call that a wrap for now. Thank you.